So this week we're going to talk about risk. Risk is critically important for environmental work. It's also very important for a lot of the kind of social work that a lot of folks do. What is risk? First of all, it's the potential of gaining or losing something. There are many, many, many things in life that are critically important in the face of uncertainty. Uncertainty is everywhere. Life is unpredictable. But we need some degree of understanding the unpredictable in order to deal with it. So why do we worry about it? For exactly those reasons, to understand what people value, what people fear, and what and when various risks should be managed. Trouble is, it's not easy. Why? For a number of reasons. Consider climate change. Some folks don't accept it as a reality. Some folks accept it as a reality, but do not accept that humans cause it, or even if humans do cause it, how much of it is caused by humans. Some folks think it's the most important threat to humanity, and some folks fully accept it, but even then there are a wide number of variations in what we can do about it. Also, we have a large number of things we do in our life that are profoundly risky. We drive, we eat, we take showers, we cook. If you skydive, scuba dive, work in an office, all of these are dangerous. Don't mean to scare you, but they are. But we do them, often happily. So we need some way of thinking about this problem of uncertainty. There's several different ways that people study risk. Risk assessments deal with the actual trying to create an understanding of how much risk exists. Risk perceptions, how people understand the risks they confront. Risk management, how people control the risks that they identify. And risk communication, how we talk about risk. Some of you, for instance, may work in the STI field. In the STI field, talking to somebody about how to acquire or not acquire a given STI is very sensitive stuff. Well, in the environmental domain, there are lots and lots of things that are similar. In fact, there are many types of hazards we have to worry about: biological, chemical, physical, cultural, lifestyle, and financial. Each of these has high degrees of uncertainty in many cases. We have to deal with this uncertainty problem. So in its simplest form, risk can be thought of as a calculation. That's what risk assessment tries to do. It tries to come up with a mathematical likelihood of harm from a given experience. So if you think about it, it could be risk equals the event, whatever it is: driving a car, drinking a soda, swallowing something radiological, divided by the total number of times people experience some sort of threat or unpleasant consequence from it. So if you think about it, it's a little like assessing how often a car accident will be. For every million miles, X number of accidents occur. The rub, of course, science is imperfect for many types of threats. Many, if most possible threats cannot be adequately counted. Exposures might be rare or might not have happened enough times yet. And even then, people might not accept what the science shows. Or what if there's no alternative? We have to drive in a car, right? So if you find something that is of high risk, what do you do about it? So again, we do risk assessments. They can be qualitative, quantitative, or some combination of both. In our field, we're talking about human health risk assessments. So how likely is a problem to our human health or to the ecology in which we sit? So here are a couple of different models that people use. Qualitative assumes the risk is there, so we try and reduce the harm. And quantitative, again, is a mathematical process with several steps, which the calculation of actual risk is the solution. Here is the model that people use for this. It's called a hazard risk assessment process. You identify the problem or hazard. You measure its exposure. You measure its dose response. In other words, so what are the health problems at different exposures? And then what is the extra risk by people who are exposed to it? In our domain, one area that we're very interested in is the problem, of course, of cancer. There are many things that are in the environment that cause cancer. So when you do a characterization, there's sort of three possibilities. It might cause cancer, it probably causes cancer, or it definitely causes cancer. How we can assess these things is based upon the research, the data that we have to support our perspective. Many different types of research are done. We can use epidemiology. We can use animal studies, we can use mathematical studies, we can use structural functional relationships, we can identify active components in the metabolism, all different ways this can be measured. All of these hopefully will give us some idea of how risky various types of things are. Here are the types of studies that people often use for human studies. They use case reports, they use case series, they use descriptive epidemiology. All of these are techniques. We're not going to go into them, but you will commonly read about if you're reading about these hazard evaluations. Here are some of the other types of studies that people do. The issue is, with these studies, there are ethical concerns. They're expensive. Sometimes diseases and consequences don't occur for a very long time after the exposure. And there are all kinds of practical considerations. Those of you that have taken your research courses know about some of these: sample size, response rate, bias, all sorts of things. But then we get the problem that people do not value risks the same. Sometimes experts will see the probability and the consequence, but people in the public will see something different. They'll see a hazard and they'll experience some kind of value relationship to it, which is called outrage. So we have this idea of probability versus consequence, or hazard plus outrage. Outrage refers to the level of public anger and concern about environmental risk. It can actually have a greater influence on reactions than a scientifically calculated risk. When people become outraged, if they overreact, difficult consequences for solving the problem occur. Here are a number of reasons that go in, factors that go into outrage. Whether it's voluntary, involuntary, whether it's natural versus industrial. Is it fair? Are the risks shared equally? Is it something we're familiar with? We're very familiar with driving a car. We're much less familiar with benzene or a nuclear power plant. Events that are very memorable versus those that are in passing. Some things that we dread. Everybody has certain kinds of dreads. And of course, uncertainty, what we can know versus what we don't know. It's a really fascinating field, and I hope you get a chance to look at some of the literature related to this, because it is interesting to see how people value different kinds of risks. Here's a few more. The morally irrelevant. We value people differently, right? So some people were willing to accept risks, other people's were not. It's horrible. Can we control it, or does the system control it? Who's telling you about the risk? Are they trustworthy? Are they untrustworthy? And how much say have we actually had in determining whether the risk exists or not? So here's where risk management and risk communication come into it. Risk management involves various tools for controlling or eliminating risks: primary prevention, secondary prevention, tertiary prevention, very important words. Primary means you're trying, I'll give you some definitions of those in a second. So yeah, here's the general model that people often use. So just go take a look through these next slides that talk about the study of this problem. You can see how complex it can get real simple, real quickly. Risk communication, the balance between risk and outrage. How do we talk about it? High risk, low outrage, radon and lung cancer. Very, very, very risky, but we don't really have a lot of outrage about it. On the other hand, asbestos in schools, reasonably low risk, but we have a lot of outrage about it. The media tends to amplify these risks, making them more difficult to work with. And again, the voluntary versus involuntary issue. So look through the next few slides. They'll again sort of go into some of the issues in determining risk. The point, again, to walk away from this lecture with, however, is that risk is how we make those determinations of what to control and what not to control. When we find a problem, what do we do about it? Most of the environmental issues we're talking about in this class, this semester, are things that are reasonably high risk. Some of them are somewhat low risk, but we have to find ways to address them. So, enjoy the rest of the slides. Have a great week, and I will talk to you later. This ends the lecture.